We were talking about visual composition, more specifically the color theory part. We had talked about additive color model yesterday. Uh, Another model, obviously the opposite of additive, is subtractive color model, and this is a CMYK color model, which is based on the CMY color model. C stands for cyan, M stands for magenta, and Y stands for yellow. And K we had discussed yesterday also. I had mentioned that in my brief that when we were talking about the different theories and the basic intros, that K is usually taken to be as black. So this model is primarily used in color printing, and is also used to describe the printing process itself. So mostly in these printers you have 4 ink plates that are used for color printing. It basically works by partially or entirely masking colors on a lighter, usually white background. The ink reduces the light, and otherwise it would be reflected. So as the word suggests, so basically you are subtracting colors. So in additive you add, so red plus green makes something, red plus yellow makes something. So that's how it works. And CMYK is basically subtractive. So cyan and magenta, when you overlap that, so you get a formation which is blue and red and green as it is shown in the image. So when white light minus red leaves cyan, white light minus green leaves cyan. So we are subtracting color from white light overall. So that is how this thing works, and these are the primary models that usually are followed. So I just have brought a few examples for you as well. When CMY secondary are combined at full strength, the resulting primary mixtures are red, green, and blue. And mixing all three gives an imperfect black or a perfect gray. So this topic basically requires a lot of graphic images so that it is understood well. But we are not going to keep our pedagogy in this particular complete manner in all the topics, for all the topics. We would be mixing it. I would want to bring a classroom experience to you also, with the help of whiteboard and everything. So we would do that, but that would depend on the kind of topic that we're discussing. Because without images, I don't think this is very understandable uh, for somebody to get a good hold of color theory. So you need to have a lot of images. So that is what is here. So if you see the differences, how the mixing of colors is and how the image is there. So it is basically a magnified image under a microscope. So you see how different color tones are created, and subsequently you have some things known as half tones. So I'm sure you must have heard about it. And I again repeat, if you have any doubts, I would strongly recommend you to please put in a message in the chat box, so that whatever your doubt is, it is dealt with well, and you are understanding it at this point itself. So this is the way with which we would be going forward. So we were talking about half unsatisfactory. So वो black का जो effect है, that is always very good. So they use black in addition to the subtractive primaries. So K in CMYK represents the key line or black plate. You must remember this. This is very important. Uh, Traditional preparation, there was a different thing. A red key line on the black line art marked the outline of solid or tint color areas. So that was it. In some cases, black key line was used when it served as both a color indicator and an outline to be printed in black, because usually the black plate contained the key line. So this is a thing which is uh, very commonly asked. So K is, this question is very repetitive also. So you remember this. These combination you play around, right? I always suggest students to go in the MS Word document, or maybe PowerPoint, or any such tool. If you have any drawing software, Photoshop or something, even in there it is again very vast. Various ways with which you do, so you will be seeing different modes of selecting colors in those tools. So if you do that, I think that helps you create identity. And there could be a question that could be asked, that if you mix that so and so color in so and so amounts, So you should be able to get that value. So like in RGB we had discussed like 250, 500 and 0. So in CMYK also 4. So again there are these things, and we will be talking about hue and saturation also later on. So that is also important. So you try it again, a small task, you try it at your end and see if all the things work out well. If you have any issues and any queries, you please ask. That is always recommended. So can you see it on your screens? Just tell me. Okay, okay. All right. I am so happy to see your responses. So let us just attempt this question. The first one says that when you take additive color mixing as reference, what is the result of mixing equal amount of red, green, and blue? What would happen? So you please, from your end, you give me an answer. What would happen? Okay, so B6 says that something would happen. Let me just wait for other people's answer. So then we will discuss who is answering correctly, or even if it is incorrect, no problems. But don't feel shy. Just respond, and it would do a lot of good to everyone. Okay, so we have varied answers now. That is also very good to understand the psyche of everyone, how things are. Okay, all right. Okay. Nia, please respond. Please just read this question and just see if you are able to answer. And B5, I want an answer from you also. Okay, this is very interesting to see now. I mean, three people have answered, and three people have answered all different options. This is very interesting. Okay, so I am waiting for B5 to answer. Okay, so I was expecting ki everyone would be answering differently. But anyways, so I think there are two options. So should I announce it in the class also your answers? Would that make it more interesting, or should I just stick to telling you what is the correct answer and going forward? Just write it in the chat box. Tell me, B5, 6, B5, B6, B7, and Nia. Should I discuss? I mean, I'm okay. Is it okay if I discuss your options, or should I keep it as in the chat book? Acha, you have mentioned it to everyone. Okay, then it's not a problem. Okay, discuss. All right. So I think you have all responded to everyone. I was thinking that you have just responded to me. So then everybody is knowing what everybody is answering. Acha, despite that you people are answering. So next time what you do is when you give your answers to me, na, you just message it to me. Okay, if there is an option, I'm sure there's an option in that. No, if there's none, then I think you put it to everyone. That is not a problem. Okay, so if everybody is saying, okay, very good. So, you see B6 and B5 have answered A as their option. And, Nia is saying that C is the option. Let us just have a look at the option. So, B5 and B5 and I think B6, yeah. They've answered as that the answer would be black. RGB, if they would be in mixed value, it would be black. Okay, so I think let's just wait for the answer. B7 says the answer should be none. So you think that neither blue nor black or white is worthy of being that color. Okay. And what about Nia? Nia says C. Okay, Nia says C. So chalo, let me give you a little background, because we have already discussed this thing. Since it is a additive color mixing, so what you are doing is you are adding these three colors, right? And if you're mixing all these colors in equal amount, what should be the color? Right? These three are the primaries, right? So all the colors would be forming out of these colors, isn't it? And if all the colors are forming out of these colors, so don't you think that what you get is basically combined effect of all the colors? And what exactly is that? Can you write it in the chat box? What happens when we mix all the colors with each other? Tell me. White. So what should be the answer? Which option should be there? So B6 very rightly mentioned white, right? So B6, do you know your answer where you were going wrong? Okay. So should we move on to the next question? Okay. So I hope you're doing this thing at your end, this whole scheme, additive and subtractive. There are certain colors which are mentioned. So, you have a box which is, mentioning primary colors. Then you have mixture of two colors. And you have, a dotted line which says that, mixture of three colors. So you put in a color and you see if you have any doubts in that and you ask me. If no doubts, then we will move further. Okay. Okay. Okay, so you are not given a guideline. Okay, so nice to know your names at least, Shri Vidya and Lavanya. Okay, okay, okay. You have any doubts, Shri Vidya? You have mentioned a comment. Uh, you have any doubt with respect to that in additive? So you are telling me that mixing of three colors.
Yes, sir.
Okay, 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 okay. All right, all right. I mean, I am so glad to hear voice, but I was told that you are always on mute. So I mean, okay. All right. So can we move to the next question? I think this is quite easy to understand, right? So we have already discussed this thing that when you mix, RGB, you get, white color formation, and when you subtract, you get a white, right? So I think this is quite, understandable. So should not. So this is how it is. Then when we talk about, a concept called Newton's optics, so this is quite important. I hope you're able to see it on your screens. Have you seen this particular figure earlier? Can you please respond? Have you are you aware of Newton's optics? Because then if you're aware of it, then I would just give you a brief idea. If not, then I would get into the details of it. Okay, nobody is aware of this. Okay, so let us just get into the nitty-gritties of it. Okay, so what it says is that it is an asymmetric color wheel, which is based on as we call it musical intervals. So you are mixing different rays in amounts given by these circles that yield color Z. Okay, so you are seeing that at the top of it you have an orientation of colors starting from A. If you see at the bottom right, so A is there. So you have blue. So blue is written in a different manner here. So BLEU. I mean, in that particular language where he developed this thing, it was written like that. So blue is blue, indigo. You move clockwise, right? So from below, blue, indigo, violet, red, orange, yellow, green. So this formation is such, and then there's a Z formation happening. Do you see? So what it says is that it is basically a spectrum to a run of musical notes. So he proposed that he used Dorian mode, right? Similar to a white note scale on the piano. If anybody is aware of piano, like if somebody knows how piano works, so you would understand that it starts at D. So white note scale, when we talk about, so he divided his color wheel in musical proportions around the circumference. I think just remember this thing that he did that How he did it, I don't think it is very relevant for you, because in examination they could ask you that, Newton optics, is based on so and so thing. So you remember the musical instrument piano and how it is. So it is basically in the musical proportions around the circumference, in the arc from DE to CD, which I've already told you. So if you talk about from red, if you see, so I went from the exact opposite, blue. So if you go from red to violet, right? So I think you remember this thing, Vibgyor. I'm sure you must have heard of this. Vibgyor. I think you must have heard about this at least. Can you please answer? Vibgyor. Okay. Okay. So it is basically, rainbow, and the colors, how they are arranged. So that is there. Okay. So Vibgyor is there, and opposite, if you write it, so Roy G BIV, that's how it is mentioned. So the middle of the colors, their center of gravity is basically are shown by P Q R S T U V, U and X. Sorry, V is not there. So P Q R S T U and X. We, again, maybe to avoid clashes with Violet, I think he must have done that. So the center of circle at O was presumed to be white. So from here, white is assumed, and Newton went on to describe how a non-spectral color such as Z could be described by a distance from O and corresponding spectral color Y. So this is what he proposed, and when we talk about this theory, uh, it is, again, a stepping stone when we talk about color wheel. His experiments led to the theory that red, yellow, and blue were the primary colors from which all other colors derived. So and then you add to that the secondary colors, so violet, orange, green, and you add to that the tertiary colors, yellow, orange, and everything which is there. So that was there. Now modern day, what you do is you usually use Munsell's hue circle. Have you heard of this Munsell's hue circle, or are you aware of what exactly is Munsell's color wheel? I would, in a short while show you, but I just want to know. Okay, so you're not aware of this also. If you see in this diagram, can you see this? There are three components. There's one component which is in the y direction, which is value. Another one is chroma, and on the third axis you have a hue, right? So do you remember those formations of electric current where we used to have that thumb up and thumb down and the movement of current? Do you remember? Do you remember that? Okay, which were very confusing. No, I mean, obviously we all did that, but it was quite confusing, isn't it? Wasn't it? So I mean, let me be on camera for some time now. So isn't it similar to that when you see this? But here, we have the colors. So what is happening in the Munsell color system is basically, it is a 3D solid kind of a representation where all three colors are making, different attributes. So you have lightness also, saturation also, and hue, which is the most correct, form of depicting different colors. So if you see, in the value portion, you have, from, ranging from black to white, and the hue part is basically taken care of by different colors which are there, right? And the chroma is basically the whole brightness and dullness of that particular color. So you are basically reaching a stage where you are having very bright colors. So I think from this particular point of view, the color usage and everything is very good, and we do understand how things are. So I don't think there should be any problem. If you have any problem in understanding this, can you please tell me? Okay, understood. Very good. B6. What about you, B5 and B7? If you have any difficulty, please let me know, because this is the most used, okay, okay. And B7, what about you? Okay.